Hello everyone, this is the solution for problem 1 in homework 5. So for the first problem, uh, the density function of a random variable x is the step function ux minus 1 minus the step function ux minus 2, and the density function for random y is uy minus 1, and the random variable z is the random variable x plus random variable y. So we would like to find the density function of random variable z. There are two kind of solutions. Firstly, we want to solve it use the convolutional method. By the formula introduced in classes, we know that fz is equal to the convolution of fxz and fyz. By the definition of the convolution, we know that it is equal to the integral from the negative infinity to positive infinity on fx alpha times fy z minus alpha d alpha. So then I want to solve this function. We input the density function of x and y into this formula. It would be u alpha minus 1 minus u alpha minus 2 times u z minus alpha minus u z minus alpha minus 1 d alpha. Then we decompose the formula. It will be u alpha minus 1 times u z minus alpha d alpha. This should be minus negative infinity to positive infinity u alpha minus 1 u z minus alpha minus 1 d alpha minus negative infinity to positive infinity u alpha minus 2 times u z minus alpha d alpha plus negative infinity integral of negative infinity to positive infinity u alpha minus 2 times u z minus alpha minus 1 d alpha. Then we solve each part one by one. The solution for the first part should be u z minus 1 negative infinity to positive infinity. So that it should be bigger than 1, and z minus alpha should be if this part is not 0, then alpha minus 1 should greater than 0, and z minus alpha should greater than 0. Then alpha should be larger than 1 and smaller than z. Then if z is smaller than 1, there will be no part that it is equal to 1. So therefore it should be u z minus 1 times the integral from 1 to z d alpha. Similarly, this part should be u z minus 2 alpha from 1 to z z plus 1 or z minus 1. It should be z minus 1 d alpha, and this part should be u z minus 2 from 2 to z d alpha, and this part should be u z minus 1 from 2 to z minus 1 d alpha. And then It should be UZ minus 1. It should be Z minus 1 times UZ minus 1. Minus Z minus 1 minus 1 should be Z minus 2 times UZ minus 2, and Z minus 2 times UZ minus 2 plus UZ minus 1. It should be Z minus 3. UZ minus 3. In all, it should be Z minus 1 U Z minus 1 minus 2 times Z minus 2 U Z minus 2 plus Z minus 3 times U Z minus 3. First, we solve this problem with the convolutional method. Secondly, we want to solve it use the geometric method. So we know that P Z is smaller than Z is equal to P x plus 1 is smaller than Z. Then the density function of x is ux minus 1 minus ux minus 2. Then it should be 1 if x is larger than 1 and smaller than 2 and is 0 otherwise. Similarly, the density function for y is uy minus uy minus 1. Then it is 1 if y is larger than 0 and smaller than 1. It is 0 otherwise. Then we draw the sketch for that. Here is 1, 2, here is 1. Firstly, this is x and this is y. Firstly, if z is smaller than 1, then the probability of p x plus y. So in this area, the f and fy should have value 1, this area. So if z is smaller than 1, then x plus y smaller than z, it will never hold. It will be 0. And if z is larger than 1 and smaller than 2, so this area, the density function have value. We draw these 3 lines. And this line is x plus 1 equals y equals 1 and x plus 1 equals 2 and x plus y equals 3. If z is smaller than, it will be on this part. On this part, it will never cross the shallowed area, so it will be 0. If z is larger than 1 and smaller than 2, it should be in this area. The line should be in this area. Then the line will cross. Then we want this area. And this is z minus 1. And this is also z minus 1. The area should be the square of z minus 1 over 2. And if z is larger than 2 and smaller than 3, the line should be in between this area. And the area of the line with the hyperplane should be the area of the square minus this part. And the area of the square is 1. And this part should equal to z minus 2. And it should be the square of z minus 2 over 2. At last, if z is larger than 3, the hyperplane will always shadow this area, and the probability should be 1. In all, we could write the CDF is equal to 0 if this is smaller than 1, and the square of z minus 1 over 2 if this is larger than 1 and smaller than 2, and it is 1 minus 2 over z minus 2 square if this is larger than 2 and smaller than 3, it is 1 otherwise. Then we can compute the PDF from the CDF use the gradient. Therefore, if z is larger than 1 and smaller than 2, the gradient of this function, this square function, is z minus 1. And if z is larger than 2 and smaller than 3, the gradient of this part is z minus 2, and it is 0 otherwise. Now we have the density function. If we write it using the step function, like this, it should be fzz equal to z minus 1 times u z minus 2 minus u z minus 1. So this is this part. And plus z minus 2 times u z minus 3 minus u z minus 2. After simplification, it should be z minus 1 times, sorry, it should be z minus 1 time. This should be like this, 2 minus 3, and minus 2 times z minus 2 u z minus 2 plus u z minus 3 u z minus 3. We already solved this problem.